Hi everyone, myself Navyatha working as Assistant Professor in the Department of Cybersecurity and Data Science in MLR Institute of Technology. Today I am going to discuss about the topic Validation Based Protocol and Multiple Granularity. And my overview of presentation includes what is Validation Based Protocol, phases of Validation Based Protocol, and what is Multiple Granularity. So in the previous sessions we have discussed about two main concurrency control protocols. So what are those? So shared exclusive locking protocols, 2PL, two-phase locking protocol, timestamp based protocol. Okay, so these are the three types that we have already discussed. This is the fourth one, validation based protocol. So let us discuss first. So what is validation based protocol in DBMS is also known as optimistic concurrency control technique. So it is a method to avoid concurrency in transactions. In this protocol, the local copies of the transaction data are updated rather than the database itself. That means whatever the operations that we are going to do, that will be updated in buffer only, not in the main database. So if at all a transaction or else updations may fail in the middle of the transactions, then it will not affect the database. Okay. So which results in less interference while execution of the transaction. So here what are the phases of validation based protocol? Mainly we have three phases: read phase, validation phase and write phase. Okay, what is about the read phase? Read phase, the data values from the database can be read by a particular transaction, but the write operation or updates are only applied to the local data copies, not a actual database. So we must not interact with the actual database. Only local copies means in local buffer only we used to update the values. Okay. What is validation phase? So in validation phase, the data is checked to ensure that there is no violation of serializability while applying the transaction updates to the database. That means here, if at all we are going to update any data, any problem may occur. It will validate. Okay. If at all problem occurs, then it will roll back. Otherwise, it will commit. Okay. So here in validation phase, the data is checked to ensure that there is no violation of serializability. That means here whether the transactions are performing in a serial manner or not, one by one, while applying the transaction updates to the database. Next, what is write phase? So in the write phase, the updates are applied to the database if the validation phase, only this phase, if the validation phase is successful. So only if at all this phase is successful, then the write phase, that means the updations which we have made in this phase will be updated permanently to the database. Okay. So validation is successful. Else the updates that are not applied and transaction is rolled back. Only if at all this phase is successful, then the updations will be updated in the database successfully. Otherwise it will be rolled back. So here each phase has the following different timestamps. So what are those timestamps? Start of TI, validation TI, finish TI. Three types of timestamps here. So start of TI means if the transaction has been started, that is what the timestamp value gives the time when TI starts execution. That means if T1 starts execution, then okay. So here T1 R of A, T2 W of A. Whenever this one has been start. Okay, that timestamp value will be given. Validation of TI gives the time when TI finishes its read phase and starts validation phase. That means here, so if at all it is going to update, then the validation phase will trigger. Okay, it ends with read phase. That means acquiring the values. Okay, and starts updating. What is finish of TI? This gives the time when TI finishes execution or write phase. That means whenever it finishes its execution, then it will update a particular data into a database. That is nothing but commit phase. Okay, that is what here finish of TI. So to clear all the validation tests done by TI, then TI must satisfy one of the following three properties. One of the following. Okay, what is that one? Finish of TI is less than start of TJ. Here TI, TJ means two different transactions. Okay, two different transactions. It means TI is the older transaction and it gets finished before TJ starts. No overlap. So, if at all this condition is true, then the validation phase is successful. Okay, let us discuss. For example, this is start time, this is validation, and this is what finish timestamp. This is start, validation, and finish of next transaction TJ. This is TI transaction. What is the formula here? Finish of TI is less than start of G. What is finish of TI? Finish of TI is 15. Okay, is less than start of TJ. What is start of TJ? 19. 15 is less than 19? Yes, there is no overlap. Okay, so this will be successful. Next, what is the second one? Finish of TI less than validate of TJ. Ensures the actual write by TI and TJ will not overlap. This is also fine. Finish of TI. What is finish of TI here? 15 is less than validate of TJ. What is validate of TJ? 29. If at all the formula is like this, then there is no overlap. Okay. Next, third one. What the third one is validate of TI is less than validate of TJ. What is validate of TI? 10. What is validate of TJ? 29. This is also represents that there is no overlap. Okay. This is about the three phases of validation phase of protocol. The next one is multiple granularity. So it can be defined as hierarchically breaking up the database into blocks which can be locked. So why we came to multiple granularity? Till now we have acquired the locks. Okay. Till now we have acquired the locks one by one or else for the whole transaction at a time. Okay. So in this multiple granularity, so we can acquire the locks by levels, right, based upon the levels. Okay. So it can be defined as hierarchically breaking up the database into blocks which can be locked. Okay. The multiple granularity protocol enhances the concurrency and reduces the lock overhead. It enhances the concurrency and reduces the lock overhead. It maintains the track of what to lock and how to lock. Whatever the data that we need to lock and how to lock also. It maintains the data. It makes easy to decide either to lock a data item or to unlock a data item. This type of hierarchy can be graphically represented as a tree that will be represented here. See, this is what the hierarchical representation like tree representation. So this is what here the whole database which can be divided into areas, then again divided into files, then again divided into records. So this is a database which can be divided into areas, this can be divided into files and this can be divided into records. For example, let us discuss this one with a simple example. So this is our, for example, college or institution. One institution. Okay. And these areas are nothing but the programs. For example, right, BTech or else the branches. Okay. Here we have BTech and MTech. Okay. So in this BTech, we have the what? Second data science and third data science like this. These are nothing but files. And in this second data science, so these are nothing but the records, the students, individual records, the number of students. So in this manner, we can able to divide the data, the whole data. Okay. Here in each level, we can acquire a lock. So if we want to lock for this particular, we can lock. If we want to lock for this particular file, we can lock. If we want to lock for this particular area, we can lock. Until unless we can't disturb the other things. Okay. The other things might be free for other users. Okay. That is what the advantage of multiple granularity here. The first level or higher level shows the entire database. The second level represents a node of type area. The higher level database consists of exactly these areas. The area consists of child nodes which are known as files. No file can present in more than one area. This is what the important point. And finally, each file contains child nodes known as records. The file has exactly those records that are its child nodes. No records are present in more than one file. Okay. So hence the levels of tree starting from top level are as follows. Database, area, as I have represented in tree representation. Database, area, files and records. So here we have, I have told you that we can acquire the locks. So there are 3 additional lock modes with multiple granularity. What are those? Intention shared lock, which is represented by IS. Intention exclusive lock, which is represented by IX. And shared and intention exclusive, which is represented by SIX. Okay. So what is intention shared? It contains explicit locking at lower level of tree but only with shared locks. Lower level of tree but only with shared locks. So it contains explicit locking at lower level of tree, that is to records like that, with exclusive lock, shared locks, both. Here we can acquire exclusive locks and shared locks also. So here shared and intention exclusive lock. So this is a lock mode. The node is locked in shared mode and some nodes is locked in exclusive mode by the same transaction. Okay, these are 3 different types of lock modes in multiple granularity. So what we have discussed in this session especially, so here we have discussed about multiple granularity and validation based protocol. In validation based protocol we have seen 3 phases. Okay, and in multiple granularity the whole database or the whole thing will be divided in a hierarchical manner in the form of tree representation, and for each level we can acquire locks. Okay, thank you.